Hello dear students, hope you are great. Today we are going to take chapter 1, matter and its properties, section 2, states of matter. States of matter. We have 4 states of matter. First, solid, liquid, and gas. Sorry, we have 4 states of matter: solid, liquid, gas, and plasma. When you change from solid to liquid and from liquid to gas, this process called changes of state. So, like for example, we have here ice, piece of ice, which is a solid state. Ice, which is solid state. When you change from ice to liquid, this process called melting. Liquid this process called melting. And if you change from water to water vapor, gas to water vapor, which is in gas state, this process called boiling or evaporation, boiling. This change of state is a physical change, as we observe that solid or ice, which is made of water, ice made of water, change to water, which is liquid, and also liquid made of water. And in boiling process, when change from liquid into water vapor also made of water. So the matter that made up each state didn't change. So this is a physical change, not chemical change. So change of state is a physical change of substance from one state to another. When change from ice to liquid, from ice which is made of water, it turned into liquid also made of water. And when change from a liquid to gas or water vapor made up of water. So the matter that made up each process or each state didn't change. So this is a physical change. We have 4 states of matter. First state, which is liquid, solid. The matter in the solid state has a definite volume and definite shape. Look here, this is a piece of ice, has a definite volume and also definite shape. For example, piece of quartz or coal, keep its size and its shape. Solid have this characteristic because the particles in them are packed together in a relative fixed position. Look, particles in a solid state are closely packed, like this, closely packed. So the solid has a definite volume and shape. Second state, which is liquid. Matter in the liquid state has a definite volume but an indefinite shape. Look here, for example, look at the juice in the pitcher. It takes up space in the pitcher. Look, when you put here a juice, the juice take the shape of the container, or take the shape of pitcher. If you pour the juice into a glass like this, it also takes the shape of the glass. It takes up the same amount of space as in the picture, but it changed shape and take the shape of the glass. Liquids have this characteristic because the particles in them are close together but can move past one another. Look, the particles in a liquid state are close packed but can move past one another. Look, can move past one another. The particles in a liquid move more rapidly than those in a solid. So the particles in liquid can move more rapidly than solid. Third state, which is gas. Matter in the gas state has neither definite volume nor definite shape. Has no definite volume and definite shape. For example, given quantity of helium, when you want to expand the balloon with helium, the helium fill any size container and take the shape of the container. So the helium take the shape of the container and can fill any size of the container. So all gases have their characteristic because they are composed of particles that are moved rapidly. Look, particles of the gas move rapidly and are at the great distance from one another. So at the particle far past from one another, very rapidly and at the great distance from one another, compared with the particle of liquid and solids. Far apart. The particles of the gas far apart. Plasma, which is a fourth state. An important fourth state of the matter is plasma. Plasma is the high temperature physical state of matter in which atoms lose most of their electrons. Particles that make up atoms and break it into charged particles. Plasma is found in fluorescent bulb. Fluorescent, which to emit a light. This is a fourth state. As the plasma is a high temperature physical state of matter. Atom that made up plasma, it lose electrons, lose particles or lose electrons and become charged particles like fluorescent bulb. So for example, neon is a substance which is made the light bulb. What happened to the neon? At high temperature, neon lose electrons. Around the neon is electron. When you lose electrons, it becomes a plasma. So we can use neon into a bulb or into a light bulb, in a fluorescent bulb, which is a fourth state of matter. Changing of states. Melting, the change from solid to liquid. When I melt solid or ice, change from solid to liquid, this process called melting is an example of change of state. Boiling, when you boil water or a liquid and turn into the liquid turn into gas, this process called boiling. Freezing is the opposite of melting. When you freeze water from liquid to solid to ice and turn into ice, this process called freezing. Is a change from liquid to solid. Change of state does not affect the identity of substance. So change of state does not affect the identity of substance. For example, when an ice melts, turns into liquid water, or when a liquid water boiled to form a water vapor, the same substance, water, is still present. Watch this video.
From the soil under our feet to the stars above, matter makes up everything in the universe. Matter comes in 4 states: solids, liquids, gas, or plasma. In solids, molecules are tightly packed and maintain their shape. Add energy, like heat, and the molecules begin to separate and melt into a shapeless liquid. More energy, and matter turns into gas. superheated gas becomes plasma, the fourth state of matter, where electrons tear away from their atomic nucleus and float freely around it. Even in cold climates, solids like this snow turn to water when heat energy pushes the temperature above water's melting point. Liquids can't hold solid shapes, but they do have volume and move to fill the space available, even space as big as oceans. While it's obvious that ice melts, even rock solids melt when they're subjected to enough energy. Rocks melted by the heat and pressure deep in the earth erupt from volcanoes as liquid magma and lava. Gas molecules are further apart and have even more energy than liquids. Gases, like air, and hydrogen gas in the universe have no fixed shape or volume. Superheated gases in the universe are plasma. Plasma makes up more than 99% of our visible universe. Its electrically charged particles are the stuff of stars. Physicist Albert Einstein came up with an equation, E equals mc squared, to help explain the relationship between energy and mass. The simplest interpretation suggests that matter can be converted into energy and energy into matter. The theory helps explain the curious beginning of the universe when an enormous amount of energy.
That's it. Thanks for watching.